Okay, everybody, this is Stephen Pugh. This is City and Guilds. This is Health and Safety, video number 5. And we're going to be talking about lifting operations and lifting equipment regulations. It's called LOLA, Lifting Operations and Lifting Equipment Regulations. This is 1998. So this is another Act of Parliament. Let's talk about some of the features of this part of health and safety. In these lifting operations, there needs to be a strong and stable enough lifting facility, okay, and it must be marked and it must indicate what are the safe working loads. Now you might have, say, a scissor lift. These things go up and down, but it will be marked as to how much load it will be able to take. Usually that load is quite substantial, but you need to be just careful that you don't overload it. It must be positioned and installed to minimize risks. You don't want it to fall over. You don't want it to come into contact with electricity. There's lots of things that you need to consider. It must be used safely, i.e. the work must be planned, it must be organized, and it must be performed by competent people. This is people who are used to doing it, who are trained and who are confident in what they're doing. Okay, so the lifting operations and lifting equipment regulations is very important. I remember recently going onto one of these scissor lifts nearby. It went up something like about, I don't know, 2.5 meters, and I was quite surprised as to how wobbly it was. Now we need to just make sure that that doesn't topple over. Some people may say, well, they're big enough and strong enough. Well, they're big enough and strong enough, but they're also high, and that's why they can be dangerous. Now let's look at another regulation. This is the control of vibration at work regulations. Now then, you may not realise that in 2005 there was an Act of Parliament passed to control the vibration at work regulations. Okay, so this is something which controls a particular injury or a particular condition that comes to certain people in certain circumstances, and it produces what's called HAVS, which is HAVS, which is hand-arm vibration syndrome. Hand-arm vibration syndrome. And what happens is when the hand has been vibrated for long enough, eventually it interferes with the circulation in the hand, and so you end up with white fingers. Okay, and that's a particularly dangerous thing. You can have to have those fingers amputated if it goes bad. Always check the right tool for the right job. In the method statement, it should be stating what the tool should be, but whatever the tool is, you need to make sure you're using the right one. You need to make sure that the tools are checked thoroughly before you use them, that they're properly maintained and repaired to avoid excessive vibration caused by faults or by general wear. As tools get older, so the vibration increases. You may not realize that. Make sure that cutting tools are kept sharp so that they maintain efficiency. If you're cutting with a tool, say you're drilling with a heavy SDS, if that SDS bit is not sharp, then it takes twice as long to cut. That means that your hand is in contact with a vibrating tool twice as long as it needs to be. So there we are. That's something how you can reduce the effect of HAVS. Make sure that the amount of time that you use the tool in one go, okay, is not excessively long. You don't want to be using something with high vibration for an hour. You need to just have a break, let the hand regain itself, let the hand become normal again, and then come back to it. Okay, you need to avoid gripping the tool or forcing the tool more than you have to. This is to do with the tool being sharp and so on and maintained. And encourage good blood circulation. So you need to keep your hands warm. You need to keep your hands dry when necessary. You need to wear some gloves. Have a hat on, or waterproof. Use heating pads if they're available. You need to give up or cut down on smoking, because smoking reduces blood flow. And if you're using vibration tools and you're already smoking, so you're reducing blood flow, so you are increasing the risk to yourself of having HAVS in the future. And of course you can massage and you can exercise your fingers and you can do all those types of things to enable you to be protected from having that horrible condition. Now in the City and Guilds book we have a large picture of a terrible site. I wouldn't recommend anybody goes and works on that site, but it's a picture which has lots of hazards all over it, and this picture is designed to teach us to identify health and safety hazards in the workplace. I'm just going to go through them. You can't see the picture, but don't worry. I mean, if you get hold of the book, you're able to see it. Most of the carpentry and joinery and the building craft operation books have this picture in it. It's quite a famous drawing. The first thing we notice is that the workers are working without any hats on. That's an obvious thing. You know, you can look around the site. If you see people without hats on, you know there's something going wrong in their head, because they really should be wearing some head covering. I remember many years ago I was working in a large roof space 3 floors up in a factory, and it had large iron girders, steel girders crossing the roof space. And I remember on one occasion I turned around and smacked my head. Wow, I smacked it really, really hard against one of these beams. Was I glad I had my hat on? Yeah, you can brain yourself. You can actually hurt yourself really badly by doing something very simple, just not wearing a hat. Next thing is poor housekeeping. If you look at the picture, you'll see there's debris everywhere. There's tools, there's bricks, there's water, there's things on fire. There's just so many. It's a really, really disgraceful building site. And sadly, a lot of building sites are like this because the men don't have sufficient time to clear up, so they just leave debris everywhere. They do the job, cut the timber, cut the bricks, leave them where they fall. And that, of course, is a very bad practice. The next thing is that you'll notice that this picture shows that they have a fire burning. This was a very common practice in the past, having a fire burning. It's not a good practice for today, especially if the fire is burning rubber or burning chemicals that are poisonous. That produces poisonous gases, and that's not a good thing at all. You notice there's trip hazards on this picture. There's trailing leads all around the place. There's pieces of wood that people can just turn around and fall over. It doesn't have to be like that. There's chemical spills. There's a drum there on the picture with some sort of a caustic chemical in it, and the chemical is green and yucky, and it's leaking out and going all over the site. Now, we don't know what that chemical is. Nobody knows what that chemical is, but if you fall over and fall into it, or if you walk through it, then you're going to come into contact with something that's very dangerous. Falling from height, there's a guy there. He's got some scaffolding up in place, but it doesn't look as if the scaffolding is very straight. It doesn't look as if it's very safe. He's standing on some boards that are missing. He's standing without a guardrail. He's standing there without a tow rail. There's no end to the scaffolding, so he can walk straight off the end of it and not notice until he hits the floor. You know, that's the sort of scaffolding that we need to really avoid like the plague. Noise, well, there's a chap there digging with a big jackhammer. He hasn't got earphones on, hasn't got a hat on. He's working underneath his mate who's doing some brickwork. So if a brick falls, he's a goner. You know, these are very obvious things, really. I mean, an electrical, apparently there's a lead there going across the site, and it's going through the pool of chemicals. You know, you wouldn't want to be working on a site like this. And then, of course, asbestos and other dangerous hazards. Asbestos in roofing is lethal. It's very important that we don't come into contact with asbestos, or if we do, we call in specialist help to be able to remove it. Asbestos is a mineral, but it tended to be mixed with fibre very often, and when those little fibres, tiny fibres, get into the lungs, you can't get them back out again, and that will set up a respiratory problem that will last you all your life. Now, the next thing to consider on health and safety here is personal hygiene. It's very important that you keep these hands clean. Very important that you don't let yourself get hurt just because you're not keeping your hands clean. When you eat your lunch at dinner time, you need to make sure there's not chemicals on your hand. Make sure that the timber that you're touching hasn't got preservative on it, because if you're touching it and you're eating it, then you're eating wood preservative. That's not a good thing. Working with electricity. Now, working with electricity is really, really dangerous. We really need to be off our wits about us. There are lots of dangers of using electrical equipment. For example, a shock from 230 volts can kill. So the normal electricity that's in your house looks ever so innocent, doesn't it, when you put the kettle on? But the shock of the electricity coming out of there, it can burn exceptionally bad, and it can stop your heart. So that's very important. Electrical faults can cause fires. Now, we all know this, don't we? But none of us really take this on board. When you're seeing electricity about, just remember that electricity can burn the plug, burn the appliance, and it can set off a fire. Apparently, in houses, most fires nowadays are caused simply by an electrical fault. Wow, that should cause the fire brigade to sit up and take notice. An explosion can occur when an electrical spark ignites flammable gas. So if you've got lighter fluid, if you've got petrol, if you've got diesel, if you've got all the different flammable liquids, make sure that there are no sparks going to be around the place. It will give you a very nasty shock. Now there's some flammable liquids that are exceptionally dangerous. If you take a little bit of petrol and light it, you'll see it just makes a smoky smoke. But when you light methane, when you light things like white spirit, or if you light the worst of the lot, which is paraffin, it will go off like a flame. It'll go off like a bomb. So really need to take great care around electrical equipment. Now we need to talk a little bit about voltages. There are three main types of voltages that you'll come across on a building site. There's phase one, which is a yellow plug. If you see a yellow plug, then you'll know that that's a 110 power. If you see a blue plug, then you'll know that it's 230 volts, or the same as you'd have in your house to plug your kettle into. If, however, you see a red one, right, what you're going to discover is that that red one is 400 volts. Now, if the 230 can kill you, imagine what the 400 can do. Far more dangerous. You wouldn't even want to go anywhere near the 400 volt. The ones that you need to know about and be careful about are the 110 and the 230. In fact, on most building sites, 230 is not even available. It's only the 110. If you get a shock with 110, it's a nasty shock, but it probably won't kill you. Whereas 230 could be the end of you. Battery powered is a much safer alternative than direct electricity, and so a lot of the time battery powered is what's becoming very common on building sites, and traditionally you will see battery drills. You will also begin to see battery powered small hand planers. There's a picture of one in the book, but sadly it's got a lead on it, so I don't know why it's called a battery powered planer. And then you've got battery powered jigsaws. You know, there's a lot of tools now that are battery powered. There we are. They don't seem to last that long on site, but they are fast charging, so that's always a good thing. There's a little section in here about wiring, making sure that you can wire a plug correctly, and we recommend that people do actually understand how a plug should be wired. However, the general thinking now is this, that you shouldn't really touch wiring unless you're a competent electrician. If you need to put a plug back on, things like that, that probably would be okay. But in the main, we recommend that you don't fiddle with plugs, and that you just get an electrician to come and check it and put a pat test on it. That's another thing that we need to talk about. With all power tools, they need to have checks. They need to have electricity checks. So when you pick up a power tool, you want to look for the plug, and on the plug there will be a little notice, a little sticker. It may say on it, fail, do not use. If it's red and it says fail, do not use, that means that that particular tool has been tested and found to be unsafe. Now you wouldn't want to use that tool. On the other hand, if it says pass and it's green, it means it has been at one time passed in the past and deemed to be safe. There'll be lots of information put on that. There will be the appliance ID number, there'll be the pass date, there'll be the engineer's number. These things are little guards to make sure that this was all done correctly. Have a look at the cable. Is the cable in good repair? Has it got cuts or damage? Is the casing of the device secure, or is it cracked, or is it in poor repair? Are there any guards, or is there any tooling that's not in place on the electrical item? Is the electricity supply leads damaged? Are they a trip hazard? You know, there's an awful lot to consider when it comes to these tools. Use the appropriate equipment for the size of the job. If you're drilling a little hole, you don't need a massive drill. If you're going to drill a big hole, then you will not be using a little drill. You need to use a tool that's appropriate for the size of the job. And of course, all these tools need to be stored. They need to be stored properly. They need to be stored in their appropriate boxes, and they need to be regularly checked to make sure that they are all okay. The next thing to consider is fire. Fire needs three things for fire to continue. It needs to have oxygen, it needs to have heat, and it needs to have fuel. Now, oxygen is a naturally occurring gas which is in air, and it combines with flammable substances under circumstances, and oxidation is what happens, and that's the bright flame that we're all used to when we see fire. Also, fires need to have heat. If the fire is cooled down, like say with a bucket of water, then the fire will go out. But there's other ways in which it can be extinguished. For example, if you had a wood fire, then it would be possible to take the wood and just remove them from each other. A single piece of wood by itself will pretty well go out. So if you take the fire apart, spread it out, stamp on it, you'll discover that the fire will go out. Right. But there's a few things we need to think about the spreading of fire. Wood offcuts on a building site, lots of dust around the place, wood dust, lots of splinters around the place. All of these things will aid the spreading of a fire. Okay, so waste then must be put into the allocated bins or skips, and always replace the cap on fuel containers, you know, like petrol or any of the flammable liquids. Always put the cap back on. You never know when a spark could just jump straight in there and the thing could go off like a Roman candle. Flammable liquids, okay, they really need to be kept in a high security place. Normally they're kept in a fireproof cabinet. Smoking around flammable surfaces should be really avoided. In fact, smoking should probably be avoided altogether, but certainly not where there's a flammable substance. And just remember that dust is an explosive material. You know, like when dust blows up into the air, if a match or if a spark goes into that dust, it all goes whoosh like an explosion would. If it's in a confined space, it will act like an explosion, like dynamite. So dust is something that we need to just look upon it and understand how very dangerous dust can be. Now, you're all familiar with fire extinguishers. We all know what a fire extinguisher is. I don't know whether many of us have ever really used one. They're not particularly great. They last only for less than a minute. And sometimes they're good if there's a very small fire. But the point is, in the main, you might want to use one and get out of the building pretty fast. Or if you don't think you can get out fast enough, then you don't even use the extinguisher, you just get out. Okay, but there are 1, 2, 3, 4, 5, there are 6 different types. They're all slightly different colours. Okay, we need to just become familiar with these things. The A class of fire, okay, needs to be dealt with by a water, foam or dry powder or a wet chemical. Okay, that's the A type, and that's for fires that are burning wood or paper or hair or textiles. The second one is class B fire, and these are flammable liquids, and these can only be put out with foam or by dry powder or by CO2. The next one is flammable gases. Now this is interesting. Flammable gases can only be put out by dry powder or by CO2. If you try to throw water onto it, the water will spread it and it will mix with the flammable gases and cause an explosion. The D type of fires are flammable metals. Now that's a different matter altogether, and these need specially formulated dry powder to put them out. What the dry powder is doing is it's smothering it and taking away all the oxygen to stop it from burning. Okay, the E type of fire is electrical fires. The only thing you can do with electrical is CO2 or dry powder. CO2 is the preferred method of putting it out. You need to just be a bit careful of CO2. Obviously CO2 is not something that's going to hurt you that much, but however it does take away oxygen from the room, and that means that you may need to get away from it to be able to breathe properly. And then F type of fires, this is to do with cooking oils, and the only way to tackle a fire of this nature is either with a wet chemical extinguisher or with a fire blanket. Now fire blankets are ever so innocent looking things, but they're very good at putting a fire out. There's another thing that doesn't come onto the list here, which I think is very important, and that is the sand bucket. If you go to service stations, you'll find they'll all have a sand bucket, and sand buckets are exceptionally good. All you have to do is put your hand into the sand, take a big handful of the sand and throw it up into the air over the top of the fire, and as the sand comes down it'll just smother it and the fire will go out. It's exceptionally good fire extinguishing facilities. Okay, we need to look at emergency procedures. Now every site that you go to will have an emergency procedure. Normally there's a sign up which says fire action if you discover a fire. Have a look at that, have a look at what it says on it, find out what it is that this particular site is going to do if there is a fire. If you discover a fire or other emergency, you will need to raise the alarm. You will need to shout for the designated person, whoever that might be. If you're the first on the scene, then you will need to ring the emergency services. You need to be aware of the alarm signal. Is it a bell, or is it a voice, or is it a siren, whatever. Find out what the siren is so that you can then respond to it when it happens. The next question is, where is the assembly point? If there's a fire on a building, sadly, a lot of fires on buildings are very dangerous indeed, because a lot of the timber is exposed. It isn't enclosed with plasterboard to make it less fireproof. So therefore, if it's an open structure, the fire will rip through it very, very quickly. But you need to make sure you know where you're supposed to assemble. There's no point sending some firemen into a building looking for you if you're around the back hiding. You know, you really need to come back to the assembly point so that they know that you're safe and they haven't got to go looking for you in the middle of the fire. And how do you know if it's safe to re-enter a building? Well, you only know when it's safe to re-enter a building when the fire officer tells you that it's safe to enter the building. That's the only condition that you're going to know about. Let's think about the next one, which is signs and safety notices. Around a building site or in a workshop, you will see certain signs. If it is a round sign or any other sign that's red with a cross through the middle or a line through the middle, that means it's a prohibition sign. You are not allowed to do this particular thing. However, if it's a sign that is blue, then this is a sign telling you that you must do something. If the sign is a triangle, yellow or red or whatever, then it is a sign warning you of some sort of danger that you need to take caution about. If the sign is a rectangle but green, then that's giving you information. Okay? It's telling you, for example, where to find the first aid. It's telling you, for example, where to assemble in the case of a fire. And lastly, there's other signs. Usually they're white. Usually they accompany the other signs and they give supplementary information, telling you extra details about what people are expected to do, what you are expected to do. Okay, so that's the end of this health and safety unit at this moment. What we're going to go is straight on through the book into other aspects of this course, and we look forward to speaking to you on the next occasion. So bye for now then. Bye bye.